We have a systems of equations here. It is important to understand that the SAT only gives you linear ones, so they're not going to give you quadratic ones like we do in class. So, keep that in mind. It's a little bit nicer than the ones we've been doing. For this one, there's multiple ways you can do this with elimination. For example, it might be pretty easy because they're more lined up here. But I'm actually going to do this with substitution just to kind of, it's kind of how I always do it. So first thing I'm going to do is I'm going to do the substitution on this second one here because it's a little bit easier to work with for, in my opinion, I guess. So it's going to be 2y is equal to 3x plus 6. So I added the 6 over, added the 2y over. So you end up with something like that. And then I'm going to divide both sides by 2. So then you have y is equal to 3 over 2x plus 3. Okay. From here, I'm going to distribute, or I'm going to substitute this for the y up here. Okay, so I'm basically going to rewrite that to be 2x minus 3 times 3 halves x plus 3, and it's going to be equal to negative 14. So if I solve this out, I should end up with x because there's only one variable, and if there's one variable, you can solve for it. So it's going to be 2x minus 9 halves x minus 9 is equal to negative 14. Okay, I'm going to combine these two things right here. So it's going to be 2 minus 4.5 essentially, because 9 over 2 is 4.5. So that's negative 2.5 x. I'm going to add 9 to both sides, and this should be equal to negative 5, which would mean our x is equal to 2. Okay. But we are looking for x minus y. So we still need to figure out what the y value is as well. And luckily we have a y equation right here because we substituted. So your y is going to be equal to, if you plug a 2 in there, it's going to be 3 plus 3 is 6. So x minus y is going to be 2 minus 6, which is negative 4 for the final answer.